The first topic for discussion I had indicated is on the syllabus is the scientific method. And I want to cover 3 or 4 related sorts of issues that are fundamental to social research, at least to empirical social research. The first of these is the researcher's target group. That is the group to which or about whom the researcher ultimately wishes to talk. Clearly, researchers seek to talk about populations. Researchers seek to talk about populations. By populations, neither I nor the researcher necessarily means everybody in the world, or everybody in the United States, or everybody in Texas, or even everybody in Houston. Clearly, populations, target populations, differ as a function of the research. Those target populations may be women between the ages of 18 and 35. The target population may be people with elevated blood pressure. The target population may be university undergraduates. But it's important to know, to understand, that ultimately researchers wish to talk about populations. At the same time, you understand entire populations typically are not available to the researcher. It doesn't make any sense to suppose that the researcher can interview or observe or in some way access all women between the ages of 18 and 35, or all people with elevated blood pressure, or even all college undergraduates. So that instead, researchers observe samples, what you may call samples. Researchers observe, researchers take a look at samples. Researchers observe samples to make inferences about populations. That is, while a researcher may seek to make generalizations, general statements about an entire population, the researcher must in some way select a subset of that population, that is, a sample. Well, this is not, here we go, that was my first problem. A sample, and then make inferences from the sample to the population. You understand, or you should understand, this is pure magic. This is absolute magic. First of all, nobody is interested in 127 undergraduates at the University of Houston. Nobody is interested in 1,017 women between the ages of 18 and 35, and nobody is interested in 21,204 people with elevated blood pressure. What everybody is interested in is the respective populations. That is, all university undergraduates, all women between the ages of 18 and 35, all people with elevated blood pressure. How on earth, what sense does it make to suppose that you can look at 124 university undergraduates and make generalizations, valid generalizations, to an entire population of university undergraduates? Or examine 1,274 people with elevated blood pressure and make generalized and valid statements about all people with elevated blood pressure. This is fundamental magic. This is fundamental magic. If I set you the task at the beginning of the semester of making 5 valid general statements about all women between 18 and 35, I suspect that you would come back at the end of the semester and say, we can't do it. There's no way we can do this, because even if we look at all but one woman between the ages of 18 and 35, there's no reason to suppose you need to sit down. There's no reason to suppose that the one person who has not been observed is necessarily described by those who have been observed. If I were to take everybody but one person in this class, gather information about their grade point average, and compute the average of those scores, and find that it's 2.74, how likely is it that the person I have not observed has a GPA of 2.74? It's enormously unlikely. But that's how empirical social research functions. And those statements, those inferences made from the observation of samples to populations can be considered valid to the extent that certain assumptions about the data and how the data is gathered and how the data is analyzed, as to the extent that those assumptions are met. But I want to emphasize to you 2 things at the very outset here. One, researchers seek to make statements about populations and not about samples, because nobody in the world cares about samples. And 2, that the process that allows researchers to do that is fundamental magic. Okay. And what we're going to spend the semester doing is working our way through that fundamental magic, so at the end of the semester you go, that's not magic at all. Okay. There are 2 general methods of inquiry. There are 2 general methods of social inquiry. The first of these is true experimentation. True experimentation. True experimentation is typically associated with laboratories. True experimentation is highly controlled. That is, highly controlled by the researcher. Typically, this control is accrued in this way. Participants are taken to contrived and controlled settings, such as a laboratory. And by controlled, I mean an environment in which the researcher has control over what enters the environment and what does not enter the environment. The researcher then observes the participants under one or more influences and makes conclusions about differences between participants, or more specifically, between groups of participants. For example, if I were interested in person's behavior in initial encounters, and I were using true experimental methods, I could bring participants into a laboratory And that laboratory is not filled with Bunsen burners and all of those things, whatever they are. It might be a laboratory that is furnished to look like a living room. So by laboratory, I do not mean some austere scientific environment. What I mean is a controlled environment. I could bring participants to that controlled environment, some participants, and I would pair up participants, one with another. So I had a zero history pair. That is, two persons who had never met before. In one instance, I could match persons on the basis of gender. That is, males with males, females with females. I could place them by pairs into the environment, provide them with certain instructions, and then observe their conversation. And perhaps count the number of questions they ask one another, code the sorts of questions, the topics the questions were about, measure the length of time of the conversation, and so on. In another condition, I could match pairs on the basis of gender, but match males with females. And provide them the same instructions I had provided the first set, and observe the opposite sex pairs in conversation and count or code the same behaviors. Having conducted that experiment, I would then compute averages for the two groups, and I would seek to attribute any differences between the two groups to dyadic gender. Yes. These people behaved in this way because they were interacting with somebody of the opposite sex, and it's different from the way that persons behaved when they were talking with somebody of the same sex. That's an example of true experimentation. It's highly controlled, and highly controlled specifically by the researcher, so that the researcher influences, the researcher controls those things that enter the environment, those stimuli that enter the environment, and those stimuli, those things that do not. The second general method of experimentation is quasi-experimentation, Q-U-A-S-I, quasi-experimentation, Q-U-A-S-I, quasi-experimentation. Quasi-experimentation occurs in naturally occurring environments. Quasi-experimentation takes place in naturally occurring environments. Clearly, in naturally occurring environments, a researcher has little or more often no control over what enters and what does not enter that environment. If again you were interested in initial encounters, same-sex initial encounters versus initial encounters between people of the opposite sex, and you pursued a quasi-experimental method, you might go to a bar and unobtrusively observe interactions between same-sex people and interactions between opposite-sex couples. And then you would proceed in the same way as I've described in true experimentation. You would compute various indices and compare those indices and seek to attribute differences between the two sets, between the two groups, to the gender mix. You understand that quasi-experimentation has the advantage, because it takes place in naturally occurring environments, it has the advantage of being real life. So that one can more easily generalize from the experiment to real life. And it's real life that you want to talk about. It's not some contrived life that may occur in a laboratory environment. Because as we will see later in the semester, people are likely to alter their behavior for any of a number of reasons when they know they're in an experiment, when they know they're being observed. The weakness of quasi-experimentation, which is the strength of true experimentation, is that you cannot control what enters and what does not enter the environment. You know that in a bar, conversations are likely to be disrupted for all sorts of reasons. Conversations are likely to be abbreviated for all sorts of reasons. People have to talk to one another differently, potentially in a bar, than they would in a more private setting because of the elevated sound around them. There's a multitude of stimuli of acting on participants in quasi-experimental research that do not act upon participants in true experimental research. Nonetheless, the general point here is that there are two methods of inquiry. One is true experimentation, which is associated with high levels of control by the researcher, and the other is quasi-experimentation, which is associated with naturalistic, naturally occurring environments. Are there any questions? The third topic that I would like to talk about briefly then is what drives research. What drives research? What drives social research? In the most general way, of course, what drives social research are the ideas and questions in the head of the researcher. The researcher reads about an issue, develops ideas about the issue, and then creates experiments of one kind or another to test those ideas. In a more specific sense, however, research is driven by either hypotheses or by research questions. That is, first of all, research is not some process that occurs after a researcher has willy-nilly worked her or his way through some set of literature and then goes out and does an experiment. What occurs is this. The researcher methodically works through some literature, some body of literature, and then generates, on the one hand, hypotheses, or on the other, research questions. And then designs experiments that are constructed explicitly to test those hypotheses or to investigate those research questions. If you don't know the questions you're asking or the predictions you're testing, you cannot possibly construct an experiment that will be effective, that will effectively test those predictions or answer those questions. Hypotheses involve, first of all, X. Yes, that is an X. Let's see if I can get it. I've got to learn this technology. X. And they involve Y. X's are predictor or independent variables. X's are predictor or independent variables. They are treatment variables. In a study of the effects of various dose sizes, various dosages of medication on blood pressure, the X's might be 0 milligrams of the medication, 5 milligrams a day of the medication, 10 milligrams a day of the medication, 15 milligrams a day of the medication. You have, in that instance, a predictor variable, level of dose size, that has 4 levels, 0, 5, 10 and 15 milligrams. So the X's are the treatment variables, otherwise called the predictor variables, and more generally called the independent variables. The X's are manipulated by the researcher. The X's are manipulated by the researcher. In research, the Y's are outcome variables or dependent variables. In social research, the Y's are outcome variables or dependent variables. They are variables that are measured by the researcher. They are variables that are measured by the researcher. If you are testing the effects of various dose size of a medication on blood pressure, presumably your only, or certainly your primary dependent measure would be person's blood pressure. So that you would administer the medication, presumably over some period of time, and then in some controlled environment, one suspects, you would measure the blood pressure of each of the participants. And you would do this at least once. Yes? If you were interested in the effects of some teaching method on students' academic performance, you might have more than one dependent measure. For example, if you were interested in the effects of two types of teaching method on scholastic performance, your independent or treatment variable would be teaching method, and it would have 2 levels, teaching method A and teaching method B. You might have, as your dependent measures, some measure of verbal ability and some measure of arithmetic ability. As for example, on the SAT and the GRE and the LSAT and so forth. In that instance, you would have a single independent variable with two levels, and you would have two dependent or outcome variables. The most straightforward hypothesis is that changes in X cause changes in Y. The most straightforward hypothesis is that changes in X cause changes in Y. For example, changes in level of medication cause changes in blood pressure. Or changes in teaching method cause changes in verbal ability and arithmetic ability. If you cast those in the form of research questions, the research question might be this: what is the relationship between dose size and blood pressure? Or what is the relationship between teaching method and arithmetic ability and reading ability? But you understand that research is driven fundamentally by the ideas in the head of the researcher, which are typically based on prior research, but more specifically driven either by hypotheses or by research questions. If you come across research that is absent of hypotheses and absent of research questions, my advice to you is to take that research and throw it in the garbage. Because it seems to me if research lacks both hypotheses and research questions, the researcher is essentially on a fishing expedition, simply gathering mounds of data and hoping that somewhere in those mounds of data there's some relationship between variable 1 and variable 2. And potentially, if you apply some logic or some illogic, one of those variables will be seen as a cause and the other will be seen as the effect. That is, one will be seen as the treatment variable and the other will be seen as the outcome variable. Yes? No, you press it down. I believe we're here. Is that right?
It says push right there.
Press right there. There we are.
Okay. So
for those of later generations who are watching, we'll get the technology sorted out.
So would your Y be considered like your frequency if you were to graph it in a table?
Y could be the frequency with which something occurs. For example, in medical research, one outcome variable might be the frequency with which people report to the hospital with pains in their chest before or after receiving medication.
And could you say your X could be considered a class limit, possibly?
Say that again.
Could your X possibly consider like a class limit?
We'll talk about class limits. We're not going to deal with grouped variables. That is, we're going to deal with single scores. So if you were a patient in this heart research, let's assume that we're counting the frequency with which you report to an emergency room over a period of 3 months with chest pains. You would have a score. The score would be a real number, 0, 1, 2, 3, 4, 5, 6, and so on. And so would every other participant. But the important issue in the context of what drives research is simply that hypotheses and research questions not only tell the researcher what she or he is looking for, They tell you what the researcher is looking for. And to the extent that they are absent, I would argue that neither the researcher nor you are aware of the reason for the study. You're unaware of its significance, you're unaware of the variables of importance, and you're unaware of what is seen to be or what is not seen to be either an associative relationship or a causal relationship. I've talked several times about measurement. No, yeah, I can't do this. I've talked several times in the various contexts today about measurement. And I'd now like to talk more explicitly about levels of measurement. Levels of measurement. Levels of measurement really means what kind of data do you have? What kind of data do you have and what can you do with it? Okay. The lowest kind of measurement and the least useful level of measurement is nominal. Nominal, at a nominal level of measurement, the researcher is delivered necessarily nominal data. What is nominal data? It's a rhetorical question. When I'm not asking a rhetorical question, I'll put my hand up, or I'll say that's not a rhetorical question. But this one is a rhetorical question. To generate nominal data, you simply name something. You simply give it a name. And that name is value-free. Gender is a nominal level variable. That is, gender is measured at a nominal level. There are two levels of gender: femaleness and maleness. Females and males. Those labels are value-free. There is no suggestion that one is more important than the other, that one is bigger than the other, that one is smaller than the other, that one is less significant than the other. They are simply identifying labels. When a researcher identifies or measures variables at a nominal level, all that the researcher can do is count the frequency with which each of those labels occurs. I could count the number of males in this class versus the number of females. And I could then perform some rudimentary tricks. I could compute a ratio of females to males. I could compute the percentage of the class that was female and the percentage that was male. I could compute the proportion of the class that was female and the proportion of the class that was male. But you understand that those statistical tricks are of limited value. They're of limited value because they yield limited information. In summary, the lowest level of measurement is nominal variables that are measured at a nominal level of measurement. What does it mean to measure something at a nominal level? It means simply that you identify different groups of things and give each of those groups a name, so that we can measure gender at a nominal level, find that there are two groups, and we give those two groups the name male and female. We could identify makes of automobile in the same way. American made, foreign made. And we could identify within American made Ford, General Motors, and so on. We could identify within foreign made Toyota, Honda, and so on. You understand those labels are value free. They're simply a way of identifying a particular instance. We can identify a car as foreign made and a Honda. We can identify a car as American made and a Ford. The only label that is not value free in that regard is my little piece of Japanese engineering that is a masterpiece. No, that's not true. There is no exception. There is no exception. Even my masterpiece of Japanese engineering is just a label, at least measured nominally. Are there any questions about nominal levels of measurement? A higher order of measurement is ordinal measurement. Ordinal measurement. When a variable is measured ordinally, it is placed in some relative position to the other variables. That is, when variables are measured ordinally, they can be rank ordered. They can be rank ordered. We could identify some number of kinds of automobiles and count the frequency with which they're sold. And we could then arrange those automobiles from most popular to least popular. Yes? Or from least popular to most popular. Yes? Is anybody out there? Yes? It's so rewarding to me when you go, yeah. You don't have to say anything. But just, yeah, I understand. I understand. You may be on TV, but you don't have to just... Nobody's going to see your face unless you turn around and give a big hi to all of those people at home. When variables are measured ordinally, you can rank order them. You can place them in a rank ordered list. But you cannot make comparisons between them. Simply because apparently Toyota sells more trucks now than Ford. Toyota would be ranked 1, rank ordered 1, and Ford would be rank ordered 2. You can't make statements, however, of this sort. Toyota sells twice as many trucks as Ford. or Ford sells half as many trucks as Toyota. You understand that when you rank order variables or you rank order scores, you've equalized the distance between all of those scores. So you cannot talk about them comparatively, because the difference between being rank ordered 1 and being rank ordered 2 is precisely the same difference as being rank ordered 4 and rank ordered 5. You've equalized all of the differences between the variables. It doesn't matter whether Toyota sells 1 more truck than Ford or 10,000 trucks more than Ford. They're rank ordered 1 and 2. So that the fundamental limitation on ordinal variables is that you cannot talk about them comparatively. Are there any questions about ordinal variables or ordinal levels of measurement? The next order of measurement then is interval. Communication studies often deal with interval level data. You and I, and others in social research, are often concerned about the things that we believe to reside in people's heads. We're often, for example, concerned about their attitudes, or their feelings, or their beliefs, or their values, or their motives. Whatever it is we believe clutters up the space in people's heads. Unless I'm just unaware of it, unless it's going on somewhere in Nevada where they're breeding people whose heads have a hinge back here that you can just sort of push back and take a direct look inside. You and I have no direct access to things such as attitudes or feelings or beliefs or motives or anything else of that kind. We measure those things typically then indirectly. And we do so by using questionnaires, by using scales. I'm sure most or all of you are aware of the standardized measures used often in psychology. There are standardized measures of what are seen to be personality attributes like self-consciousness or self-monitoring, or introversion, extroversion, or sensation-seeking, and so on. And typically those questionnaires, those tests, those measures, take the form of an accumulation of individual items, individual statements. I like going to parties. I hate being at home alone. I'm more comfortable with people around me. I'm very talkative. And then there is a scale next to the statement. Usually that scale is either a 7-point scale or it's a 5-point scale. And at one extreme is defined as agree, the other as disagree, or one end is described as describes me very well, the other describes me not at all well. Yes. Just some feedback. Just so I have the illusion that you understand, you feel good about yourself, you feel good about me, you're having a good time. Let's assume that you respond to such a test. And you circle the number in each case next to each statement, indicating how well it describes you. What then happens, of course, is that some of those items have to be reverse scored. Let's assume we're measuring extroversion, and the statement is, I feel more comfortable when I'm by myself. A low score on that would indicate a high score of high level of extroversion, and a high score on that describes me very well would indicate a low level of extroversion or sociability. So you have to reverse score those items. You have to reverse the polarity. But what then happens is that your responses are simply added together. You circled 4, 2, 2, 4, 2. Those 4s and 2s and 3s and 5s and 1s are added together to form a single score. And your measure on the score of extroversion is 32. That can be used diagnostically, because the researcher, given the high number of tests that have occurred, can go to that data bank and say, well, 32, you're moderately extroverted, or 32, you have a high level of extroversion. But it's more important for the present context that you can then not simply label people as having some level of extroversion. That is, it's not simply that you can define people and scores nominally. It's not simply that you can rank order those scores from highest to lowest. That is, it's not simply that you can measure that variable ordinally. It's that you can talk comparatively about persons. A person with a score of 40 is more extroverted than a person with a score of 32. A person with a score of 16 is less extroverted than a person with a score of 25. And you can maintain the differences, the true differences between the scores. The difference between a person ranked second highest with a score of 41 and the person ranked highest with a score of 46 is now not the same as the difference necessarily between the second ranked score and the third ranked score. So that interval level data allow some sorts of comparative statements, and they retain the true difference between one score and another, unlike ordinal level data. Are there any questions about interval level data? Yes. I don't think you have to pick it up.
Zero. The number 0 cannot exist in an interval. Is that correct?
0 can exist on interval level data.
Okay.
I know the question that you're getting at. I know the question that you're getting at. But you can have a score if you're 5-point scale, instead of being 5, 4, 3, 2, 1, is 4, 3, 2, 1, 0, then it's possible for a person to score 0. The important thing, however, is that that 0 is arbitrary. A person who scores 0 on a test of extroversion does not necessarily have no extroversion inside of them. It's an arbitrary 0. In the same way that 0 degrees centigrade is absolutely arbitrary. Did Moses go up the mountain, come back down, actually came down with 3 tablets. 2 tablets had the commandments, and 1 tablet said, freezing is 0 degrees centigrade. Moses, being a shrewd kind of guy, knew this was going to be important, and so kept it to himself. So we only read of the 2 tablets that he foisted upon his followers. You understand that 0 degrees centigrade is arbitrary. There is nothing magical about water freezing. Why not alcohol? Why not gasoline? Why not my left foot? Better, why not your left foot? It's arbitrary. That is a critical feature of interval level data. And it's a critical issue when we unveil the creme de la creme of measurement levels, the creme de la creme of data, the AK-47 of data. The AK-47 when you absolutely have to kill everybody in the room. That's actually not what Samuel Jackson says, but it's very close. I changed the word. The winner of this contest, don't you feel a sense of excitement growing? Who will be the beauty queen? I'm teasing you now. This is like Hendrix about to play Voodoo Child. Gives you a lot of spiel before it. So what were we talking about? The AK-47 of... What were we talking about? Of levels of data, levels of measurement. See, now nothing's... is simply I. Is ratio level data. Ratio level data. Ratio level data are magical and mysterious. They are all that other data strive to be. When data are born, when data are very tiny, data parents say to data children, you should try to be ratio level. The critical feature of ratio level data is that the scales upon which they are measured have true 0 points. The critical feature of ratio level data is that the scales that they are measured on have true 0 points, which allow for very complex comparative statements. Let's go back to degrees centigrade. We have 2 days. On day 1, it is 40 degrees, no, not 40 degrees centigrade. We're on the face of the sun. Let's do something even more arbitrary that I'm more familiar with. It's those euros, that euro trash. You know how they are. Not only do they come over here taking our jobs and, you know, if I weren't here, you know, an American could be doing this. An American could be doing this job. Let's not use that euro trash centigrade stuff. Let's use something truly American and even more arbitrary, degrees Fahrenheit. I don't know what is magical about 32 degrees Fahrenheit. Has something to do with water freezing, I think. Again, you know. You realize if an alcoholic had put these measures together, we'd be talking about something quite different here. We have 2 days. On day 1, it is 40 degrees Fahrenheit. And I am so snuggled under the covers. On day 2, it is 80 degrees Fahrenheit. Is this statement true? On day 2, it is twice as hot as on day 1. We have people saying yes. The answer is no. The answer is no. And your experience should tell you that. Because on a day that's 40 degrees Fahrenheit, I'm just about paralyzed. I don't want to go. If I go out, bad things happen. My blood starts to coagulate. No. A day that's 80 degrees Fahrenheit is not simply twice as hot as a day that is 40 degrees Fahrenheit. If you put something in the oven to cook at 300 degrees Fahrenheit and the same mix in another oven to cook at 600 degrees Fahrenheit, it's not going to take the first oven twice as long to cook what's in there. It would if on day 2, 80 degrees Fahrenheit, it was twice as hot as day 1, 40 degrees Fahrenheit. You can't make that sort of statement. Degrees Fahrenheit are an example of interval level measurement. Degrees Fahrenheit is an example. Let's get the grammar right, Douglas. Degrees Fahrenheit is an example of interval level measurement. You can't make comparisons that involve statements like twice as, half as, 4 times as much as. And you cannot do that because the 0 point on those scales is arbitrary. 0 degrees centigrade does not represent the absence of heat. 0 degrees Kelvin does. The Kelvin scale is a ratio level scale, and it generates ratio level data because 0 degrees Kelvin indicates the absence of heat. so that you can then make statements of the kind, day 2 is twice as hot as day 1 if you're measuring in degrees Kelvin. Number of questions asked during an initial interaction is an example of ratio level data. Because if a person asks 4 questions and another asks 2 questions, person 1 asks twice as many questions as person 2. Height is a ratio level measurement, because somebody who is 6 feet tall is twice as tall as somebody who is 3 feet tall. In fact, it's difficult to talk about being 3 feet tall. Just a joke. I'm not after tiny people. Politically correct crowd, huh? Are there questions about levels of measurement or differences between different levels of measurement? Depending upon the level at which something is measured, the data that's generated are of different kinds and allow for different sorts of statements, and importantly allow for different sorts of statistical tests. It's more desirable to measure variables at a ratio or interval level than at an ordinal or nominal level. So that research that uses nominal level variables, nominal level data, is not as useful, all other things being equal, as research that uses ratio or interval level data. And most communication research now uses ratio and interval level data. We've got beyond the point, thank goodness, of simply identifying things nominally or ordinally. Are there any questions? Yes.
Can you explain again why you can't make a comparison in ordinal levels of data? You're saying you can't make a comparison?
Can I explain why you cannot make a comparison of this kind in ordinal level data? When something is rank ordered, we could rank order the temperature of 4 days. Yes. Day 1, or 4 locations. Location 1, 10 degrees Kelvin. Location 2, 20 degrees Kelvin. Location 3, 30 degrees Kelvin. Location 4, 40 degrees Kelvin. We could rank order those from hottest to coolest. But if that's all we did, you can't make comparative statements because you've rank ordered them, and so now rather than being associated with their original scores, 10, 20, 30, 40 degrees Kelvin, they're associated with the numbers 1, 2, 3, 4. What you've done, and perhaps the example is clearer if I say 10 degrees Kelvin, 15 degrees Kelvin, 26 degrees Kelvin, 32 degrees Kelvin. The differences between those scores is not standard. But when you rank order them, they become 1, 2, 3, 4. You've equalized the differences between the scores, and the first score is not twice as high as the second score. In order to make comparative statements, you need data to be measured either at an interval level, but more particularly, even better, at a ratio level. This notion of twice as much as, half as much as, is a unique feature of ratio level data, because the 0 point in ratio level data is a true 0 point and not an arbitrary 0 point. Next time we will continue this discussion. Let me say this. We will continue this discussion. I do not know what, well, we will continue this discussion. Yeah, and now I want to make just a couple of announcements. One, to remind you, the bookstore did not order the text. So you know, I did place the order, and I'm willing to bring hard copy of that. Wasn't my fault, man. Wasn't my fault. But they now have placed an order for the text. Don't worry about it, because this early stuff is straightforward stuff. The second thing I want to say is, get here on time. And if you can't get here on time, come in through that door and sit down over there, or come in that door and sit down over here. Don't wander backwards and forwards so that people, subsequent generations, are going, whose head is that? And why did it go this way and then come back this way? Okay? I will see you on Tuesday.